Hello. Today I'll be talking about Zener Diode, just the basics, basically. So what is a Zener Diode? Well, if we look at what is a Zener Diode and why it is different from other diodes, okay, well, this is just to overview the Zener Diode. We can find this from online Matlin, and this is just a schematic diagram or symbol. If you look on this, is normally a diode is we just, you just go like this way, just a small, a vertical line, but the Zener diode is have a Z shape basically on here. So this is the anode and this is the cathode. So in a small signal or rectifier diodes are never intentionally operate in the breakdown region because this may damage them. However, a Zener diode, which is a silicon diode, is optimized for operation in the breakdown region. Okay, what does this mean? Well, if we look at this, is just XY graph or IV curve. So the horizontal is the forward voltage and reverse voltage. This is just a positive, and then this is just a negative voltage. If we look at the vertical line, it's just the forward current and reverse current. Okay, so if we look at this curve, it is just in the forward region or forward bias region. Okay, and then this is just a reverse bias region. Okay, so the Zener diode has a forward bias region characteristics. So for instance, normal diode is just between 0.3 to 0.7 volt. That is the forward region volt. Okay, and then the reverse, this is just like this one. And this is just the minimum current breakdown, and this is the maximum current breakdown. Okay, and this is just the Zener region. And this is, if you see on here, this is the voltage of the Zener across, just the reverse bias region basically. So, sorry, if we look at now, assume a Zener diode or a single diode is, operated at 5.1 volt in the forward region, and with IN4773A type. And then now if we build a circuit with input resistance or source resistance of 200 ohm, for instance, and variable voltage source, input voltage, and this is the type of the Zener diode, and of course a load resistor of 1.5K. Okay, and this is just equivalent this circuit built in multism software. Okay, so we have supply voltage input, okay, and then input resistance, RS, basically, and of course load resistance, and this is just the Zener diode. And then we have a voltmeter to measure the voltage between across the Zener diode, basically. So this is just a template table to measure the output voltage, which is just across the Zener diode, and then the load current, which is just the load current is across the RL, and then source voltage for around here, and then of course source current across this resistor, and IZ or Zener current across this one. You could measure or calculate basically. To calculate this, basically we need to calculate voltage across this resistance. That is, if we take away this, okay, a voltage, source voltage minus voltage output, the Zener voltage, and you can find easily the voltage across the source resistance or input resistance. And then to calculate the source current, which is around here, then we can just divide this voltage divided by the resistance. And then the Zener current, which is this one, can be calculated, just forgot the SI unit basically for now. IZ is equals to, or the Zener current across here, or on here, is equals to IS minus IL. Or IS, source current, is equals to Zener current plus load current. Okay? So now if we look at the measured or the simulation results from this small, circuit. We can see when we increase the voltage input from 0 to 10 maximum, okay, we know that the Zener diode is 5.1 volt regulated. Then the voltage output is increasing from 0 to 0.88 when the source or input voltage is 1, and then it's just increasing slightly. So 1.277 when the voltage input is 2, 2.65 when the voltage is 3, and then going high. And then when voltage input is 5, then the voltage output across the Zener diode is 4.4. And then when the voltage increases above this 5 volt, which is 6, and it just remain around 5.01. And then we increase 7, 8, it just remain around 5. If we look at it, just like saturate basically, it just regulate. And the load current is just a milliamp, which is increasing to the maximum of 2.54. Then of course voltage across this one, the source is just like increasing to the maximum of 4.92 volt, which is close to 5 volts. And the supply current is again the 222.37 milliamp. And if you look at now, the Zener current is just like also increasing a small amount, but from 0 to maximum of 20 or 90.83 milliamp. So now if we plot these test results into the graph, so if we compare input voltage against the output voltage or the voltage across the Zener, now the voltage input is from 0 to 10, and the voltage across the Zener is from 0 to around 5. So the voltage is initially increasing, but then when the input voltage is just around above 5 or around 6, it just remains around 5 output voltage across the Zener diode. Okay. And then if we compare the currents again, well, the voltage outputs, this one, the Zener, the voltage across the Zener versus the Zener current, or this is just like in the forward region, we have this kind of increase in the forward bias. Okay. So what we can conclude from here, well, the Zener diode is used as a voltage regulator because it just regulates the output voltage to be maximum of 5 volts. Okay, like 5.1 for instance, as it was specified in the specification. So which holds the voltage, the load voltage almost constant despite large change in the line current and load resistance. Despite we keep increasing the input voltage, the output voltage of the Zener diode is just keeping the output voltage constant at 5 volt. And then this is just in the reverse side. What we were saying is it can break through the reverse bias basically when the voltage increases more than the specified Zener voltage. So if you see on here, it's similar in the reverse, in the negative side, basically the reverse bias. Okay. So now if we look at on the circuit diagram, for instance, on here, so if we look at on here, when the voltage is 0, okay, we have the Zener diode. When the voltage is 0, okay, the output voltage across here is 0. So when we increase from 0 to, say, 3, say 2.6, 5.4 is 3.9 volt output. It's 5 volt on here and input voltage, and the voltage across this one is 4.4. And then if we go to above the Zener voltage, which is this Zener voltage is designed to regulate around 5.1 volt. If we increase to this one above this voltage, say for example 6 volt, now it's 5.01. But if we increase to 7 volt, still around 5 volt. 8 volt, still around 5 volt. You see, 9 volt input, still around 5 volt output. 10 volt input, still around 5 volt output. Meaning that this voltage, this Zener diode is used to keep the voltage output constant to 5 volt. Okay, so this is the reason why we say that Zener diode is used to regulate the voltage output constant, remain constant despite the change of resistance or load resistor or input voltage. Okay. All right, thank you.